Hi, everybody. These are your notes that you missed if you were gone today. Today is Wednesday, October 23rd. So yesterday we left off in our notes on the mantle, and we were talking specifically about, excuse me, different layers in the mantle. So if you haven't already, go ahead and get your notes out. Pause the video anytime. I'm just going to go ahead and go all the way through. Pause the video anytime if you need to stop it so that you can write down your notes, okay? Okay, so we reviewed two vocabulary terms yesterday, the lithosphere and then the asthenosphere. And the lithosphere, if you remember, is litho means stone or rock, and sphere means globe. So this is describing the rigid outer layer of Earth, which includes the crust and the uppermost part of the mantle. So yesterday we did a hands-on activity where we had airheads, and one airhead was super, super cold. It was kind of frozen, and that was representing the crust. And then the other one you guys had put in your pockets, and so we transferred heat to that, and that represents the magma that's in the mantle. And so both of them are the same material, but one is rigid and one is plastic. It has plasticity. It's able to change its shape. What I want you to understand, though, is the models have a limitation. I don't want you to put the two models on top of each other. I don't want you to put the hard on top of the soft and go, oh, that must be what the layers look like. There's no delineation between those two layers. It's sort of a transition. And so when we talk about the lithosphere includes the crust, which is the hard outer layer of Earth, and it's hard solid rock. And it also includes the uppermost part of the mantle, which is magma. The hard solid rock is divided into sections called plates, and the plates move on top of that mantle. And then the asthenosphere, astheno means weak or without strength, and sphere is globe. That's the warmer airheads. It had no structure, so when you held it up, it bent down, and then you could flip it over and it would bend the other way. We were able to manipulate the shape. So this refers to the mechanically weak and plastic region of the upper mantle of the Earth. And there's actually a third layer called the mesosphere. Let me kind of explain it a little bit. So if you look at this wedge shape, look on the very right. So do you see how the very top label is the continental crust? So if you look from the right to the left and you're looking at kind of that gray-brown shaded region, that's the oceanic crust and the continental crust. This is what's considered the crust, right? And then underneath it is sort of a kind of a reddish-brown layer, and that's the top part of the mantle. So on the right-hand side, you can see where there's a bracket, and that labels it the lithosphere. And then you have the orange and the red section, and those are the last two sections of the mantle. In the very middle, you'll see that there's a red square that's kind of containing all of the parts of the crust and the mantle, and blowing it up, and we can see that these are labeled there in the box. And I want to go even further. So I created my own diagram, and I wanted to kind of explain it a little bit to you. So the lithosphere is the crust, all the crust, the oceanic and continental crust, and the first 100 kilometers of the upper mantle. So the mantle is the three colored regions. The crust is the white, and we can see the lithosphere is the crust and the top part of the mantle, and then the asthenosphere is the remaining part of the mantle. This is plastic. It is molten rock. It flows like peanut butter. And then the bottom half of that is another heated layer. It's several hundreds of miles of solid rock. That is super trippy. Think about that for a second. The reason why the rock in the asthenosphere is molten is because it's getting warmed by the core. And so how can we, as we're going closer to the core, how does the rock turn solid again? And it's not as solid as what it is on the crust. It's more of like a semi-rigid, but still, like, how is that changing if it's so hot? And the answer is because of pressure. Think of this. All of that matter above the mesosphere is pushing down on the mesosphere. And so it's compacting all of that matter. And so there's really no place for that to go. A liquid likes to flow, right? Well, if you're decreasing the volume, there's not really a whole lot of place to flow. And so you're kind of freezing it as a saying. It has nothing to do with temperature. It has everything to do with a compaction of the volume. And so just a reminder, as far as like how can we describe the material here, in the continental plates and the lithosphere, it's going to be rigid. And the asthenosphere, it's going to be plastic. And the mesosphere, it's going to be semi-rigid again. Now, if you want to continue our analogy of using peanut butter to describe plasticity or the molten rock, then think of the mantle's layers as being like a sandwich. You've got two rigid layers that are on either side of a plastic layer. All right, so the mantle, we've got the crust, the mantle. I'm not really crazy about this picture. It shows the mantle. It's actually not to scale. The mantle is much thicker than that. But the mantle surrounds the entire dense metallic core. So we're moving on with our notes now. Let's talk about the core. So the core is the layer of earth that extends from below the mantle to the center of the earth. And it's made up of two regions. It's called the outer core and the inner core. I like this picture much better. See how the crust is really thin? And then you've got this huge layer of mantle. And then we have the outer core and the inner core. Now, the outer core is right here. And then, of course, the inner core is going to be to the right. The outer core is below the mantle. And guess what, friends? It's liquid. The outer core is liquid. It's liquid. What is happening? Why is it liquid? Take a look at this picture. This is a great picture. So we've got the mantle that's kind of that brownish color, and then we've got a liquid core, and then we've got an inner core. And I don't know if you're truly grasping how is that behaving as a liquid? Well, there's a really simple explanation why we go from a semi-rigid rock to a liquid outer core. And that's because the outer core and the inner core are not made of rock. They're made of iron and nickel. And so because the crust and the mantle are made of solid rock, that material is going to behave a certain way. There's a change in composition between the mantle and the outer core. It's not made of rock anymore. It's made of metals. And those metals are going to behave differently. And one way they behave differently is that under certain pressure and temperature, metal is going to melt and it'll be a liquid. So the outer core is made up of liquid, iron, and nickel. Now, the outer core is also considered to be molten metal. And here's a picture of molten metal. It is melted. It acts like a liquid. The molten rock flows, but it acts more like a soft solid than a liquid. Molten metal actually acts like a liquid. The outer core is denser than the crust and the mantle. So you're going to see this, hopefully you're seeing the pattern, that the further we go in towards the middle, the more dense that layer is going to be. So each layer is more dense than the one before it. The temperatures in the outer core can reach 4,000 degrees Celsius. And I don't know if you remember, but yesterday we talked about the sun. The sun has a surface temperature of 5,500 degrees Celsius. So we are getting awful close to the temperature of the surface of the sun. Isn't that trippy? And then if you're going to convert that to Fahrenheit, it's 7,232 degrees Fahrenheit. It's hot, friends. let's go ahead and talk about the inner core now. So the inner core is solid. At the center of the earth is the solid inner core, and it's about 1,200 kilometers thick. A couple things I want to talk about. We're going from a liquid outer core to a solid inner core. Again, the inner core is where all the temperature is, all the heat. There's a lot of heat here. So how are we transitioning from a liquid to a solid if it's actually getting hotter? I'll talk about that in a slide or two, just a second. Let's talk now about what the distance is, okay? If we're looking at the diameter of the inner core, it's about 1,200 kilometers. And I thought, well, I wonder how far would that be in miles? And that would be from Platteview Junior High to Tuscaloosa, Alabama. If you want to go watch a football game and watch the Alabama Crimson Tide, go right ahead. This is where you'd have to go. So if you think about it, that's the diameter of the core. It's truly, it's not as big as maybe what you may think. It's actually rather, I think, for being the center of the earth, the core is actually kind of small. So why is it solid? Well, if you think about it, the metal, the iron and the nickel, they're under great pressure. And so tomorrow we're going to do some hands-on activities that hopefully will help you understand temperature, pressure, and volume and how they can kind of react or how they can change depending if one of them increases or decreases. What is the relationship between temperature, pressure, and volume? But the material, nickel and iron, under great pressure, it's going to compact that matter. And so regardless of the temperature, the pressure increases, and so it's going to solidify because, again, there's no place for that liquid to flow. It's in a much smaller diameter. And so it just sort of, think about when you have 2 people in a room, you're able to move around freely. If you put 100 people in my classroom, you're not going to be able to move around as freely. So the density is increasing and the volume decreased, so that there's not as much place for the liquid for the metal to go. So it's going to become a solid. Just a reminder, because of that change in composition, the crust is hard solid rock, the mantle is soft solid rock, and then we transition to iron and nickel, which is metals. The outer core, it's liquid, the inner core, it's solid. All right, so continuing on the inner core, I love this picture. This is such an interesting picture. So the inner core obviously is the densest layer of the earth because you have all of that matter that's crammed in just a super small space. The temperature in the inner core can reach 5,000 degrees Celsius. That's almost as hot as the sun. Remember, the sun is 5,500. Did you have any idea that the core of Earth, the inner core of Earth, is almost as hot as the sun? That is so crazy to me. All right, I'm going to plow through here real quick and just finish out a couple slides. So even though the temperatures are very high, the great pressure caused by the nickel, or causes the nickel and iron to solidify. So the whole weight of the world literally is pressing down on the inner core. And all of this pressure causes the inner core to be forced into a solid state. The solid inner core is surrounded by the liquid molten outer core. And that is something that we're going to talk about tomorrow. This is what creates our electromagnetic field. And so I'm going to talk to you more about it tomorrow. I want you to go ahead and write these notes down. I think I don't have this one. It should be rotation. That should be red as well. All right, I will see you tomorrow.